Our first step is to name the variables, which means we are looking for what are varying in this problem. There are actually two things that are varying. The first, the bottom of the ladder to the wall is increasing, so we can name it x. The other thing is the top of the ladder to the ground that's decreasing, so we can name it y. Please note that the length of the ladder is always 10 feet. That's not changing, so don't name it by a variable. So now we can check what conditions were given. The first condition is 1 foot per second. That's a rate of the bottom of the ladder. So in other words, you can rewrite that by the rate of x, which means dx over dt equals to 1. What you're looking for is how fast is the top of the ladder sliding down. So top of the ladder is y. So you're looking for the rate of y. So you are looking for dy over dt. At the moment when the bottom of the ladder is 6 feet from the wall. So at the moment when x equal to 6. Please know that x is not always equal to 6. You're just looking for the rate when x equal to 6 at that moment. So now we can set up an equation involve both x and y. We find that x and y are the two sides of a right triangle. So we use the Pythagorean theory to set up an equation of x squared plus y squared equals to 10 squared. So now we can start to take the derivative of both sides with respect to t to create the terms dx over dt and dy over dt. So you take the derivative of the left-hand side and the derivative of the right-hand side. So the derivative of x squared, the chain rule will give you 2x and dx over dt because x depends on t. Similarly, the derivative of y squared, you get 2y and dy over dt. But to the right-hand side, the derivative of 10 squared, don't think it's 2 times 10 because 10 squared is 100. That's a fixed number. It's a constant. So the derivative of constant is actually 0. That's a common mistake. So now in this equation, dy over dt is the term we are looking for. And we know in an equation we can only have one unknown. So we need to find everything else. So x is 1, we already know. And dx over dt, no, x equal to 6, we already know. Dx over dt is 1, we already know. And the only thing we don't know is y. So if we can find y, then we can find everything except dy over dt. So we can find it. So how to find y? So we again use this x equal to 6 and x squared plus y squared equal to 10 squared. So you can put x equal to 6 into that equation. You get 6 squared plus y squared is equal to 10 squared. So you can find y squared is actually 10 squared minus 6 squared. That is equal to 64. So you get y is square root of 64, that is 8. So now we have everything. We just plug into this equation. You get 2 times x is 6, dx over dt is 1, plus 2 times y is 8. We just find it. And dy over dt equals to 0. So you simplify that, you get 12 plus 16 dy over dt is equal to 0. Then it's very easy to solve dy over dt. You just subtract 12 both sides. You get 16 dy over dt is equal to negative 12. So dy over dt is negative 12 over 16. That is equal to negative 4/3. No, 3 over 4. 3 over 4. The unit is feet per second. And you notice there is a sign negative. And it makes sense because y is decreasing. That's why it's negative. That's it.